Hello, and welcome to today's problem. So, we're going to find the first index of the first occurrence in a string. Given two strings, needle and a haystack, you want to turn the index of the first occurrence of needle in the haystack, or -1 if the needle is not part of the haystack. So, given this string, you would find sad, and then it occurs in index 0 and 6, but since it's at index 0, we return 0. If not, we don't get it. Okay, well, I think this is pretty straightforward. You just have to loop through every single element, every single character, and check to see if it's equal to the first element in the needle. So we'll have like a needle pointer, and then we'll have basically just loop through, and if it happens that the needle pointer is equal to the regular one, then we can go ahead and update that. And then keep going until if it reaches the length of the needle, and if it's good, then we can return that as the final value. So I'll just code this up really quickly. We're gonna have the needle pointer. We'll call this like p for pointer, and then we'll have this equal to 0, and then we'll do for I in range length of haystack. We can see if haystack I is equal to needle, needle at the given pointer, then you want to keep iterating through forward, adding 1, so p plus equals 1, and then if the length of the pointer, if the pointer is equal to the length of the needle -1, then we can go ahead and return the index that you're on. So you return I. Otherwise, you just return -1. And then, yeah, that should be it. I think so. Oh, let's have a look here. Output is 2 when you want to return 0. Oh, I see what's going on. For I, haystack I, we'll have cur. We'll set cur to be equal to 0. Or set cur to equal to I, and while haystack cur is equal to needle p, then you want to check to see, we want to increment this, and then we want to increment the cur as well. So cur equals p plus 1, cur plus 1. We set that, and we keep moving this forward until we turn -1. Okay. This one turns 5. So if p equals length of the needle and cur and a haystack, again, length of haystack is minus 1 is okay, I see. So we need to contain everything. So we also want to do if p is, if it's in the subsequence. So you want to do check if p is equal to length of needle -1. And then p also has to be, the pointer also has to be equal to, oh, strange. We have 1, 2, 3, 4 elite, and we have O here. Maybe it should be if it's equal to here. Yeah, actually, yeah, you're right. P equals P plus 1, curve plus 1. Let's run this again. Lito. If P is equal to the length of the needle minus 1, then you want to return I. Because that means you've reached the end. Yeah. Let's do a quick print statement on where P is at this given point. One, two, three, four. So it needs to do another comparison. So the issue of the problem was actually that I need to reset P to equal to 0, and then I also need to have a check to see whether or not the current is less than the haystack before we could run this. But generally, other than that, the logic is correct. So thanks for watching.